Hello viewers, wow, it's my pleasure to receive you on this platform. In this video, I would like to share with you two tutorial questions which has to do with Venn diagram within the scope of set theory. So sit back as you watch. So let's consider the first tutorial question. If A and B are two sets that contain something, which means that A and B has elements, which means that A and B, they are non-empty sets. So the task now is that A symmetric difference of B is equivalent to A minus B, then union B minus A, which means that there is a particular expression for A triangle B. And in this case, what we are trying to say is that A triangle B is equivalent to the difference between A and B union the difference between B and A. Now the task here is that if we have another non-empty set C, then we are to use the concept of Venn diagram to show the region of A intersection C, then triangle B intersection C. This is the first question we are going to address in this video. So I advise you to sit back and watch. Thank you. Just like I've introduced to you in the class, you see that in this case we have three sets, A, B, and C. And our major assignment now is to use Venn diagram to show the region. So let's consider a triangle A, B, and C in such a way that each of them have something, as we can see. Now, what does it mean now? We can see clearly now that from here that set A is 1, 2, 4, and 5. What about set B? Set B is 2, 3, 5, and 6. What about set C? Set C is 4, 5, 6, and 7. So the next thing now is for us to quickly obtain what is A intersection C. What is that element in C? And it is also in A. Or if I can say it this way, element that is in A that is also in C. And that is what? 4 and 5. So let's call that one X. Let's proceed again. What about B intersection C? What is the element we have in B and we also have in C? And that is what? 5 and 6. So let me call that one Y. So in summary, what we're actually looking for, which is A intersection C, triangle B intersection C, is now the same thing as what? It's the same thing as S triangle Y. That is exactly what we are looking for now. So you can now see now that we have our X, we have our Y. So after we have this, we can now proceed to the next step. But don't forget that A triangle B is what? A minus B union B minus A. So if this is true now, what does it mean? It implies that X triangle Y that we're looking for is also the same thing as what? X minus Y, then union Y minus X. But don't forget that we already know our A intersection C, which is 4 and 5, and we call it X. We already know our B intersection C, which is what? 5 and 6, which you call Y. So in this case now, let me now call your attention to X triangle Y. This one will now give me 4 and 5 minus what? 5 and 6. Then in the bracket, let's find the union. Then the next one is 5, 6 minus 4, 5. So in this case now, how do we get our difference between two sets? Just like we explained to you in class that 5 minus 2 is what? 3. And that 3 is in 5. So the same thing applicable. What do they have in common? They have 5 in common. So we remove 5. So the remaining item in the first set, that is 4. And for the second one, that is 6. So we can now say that X triangle Y is equivalent to what? 4 and 6. Now we can now finally produce the Venn diagram using the fact that what we are looking for is 4 and 6. So let's go back to the template that we used. And in this template, you can see now that we have 1, 2, 3, 4, 5, 6, 7, and 8 in it. So what we are looking for is that we are to shade the region of 4 and 6. So let's shade 4 and 6. Let's shade 4 and 6 then you now see that we're going to come up with this particular Venn diagram. So this Venn diagram is equivalent to A intersection C, then triangle B intersection C. Don't forget that this diagram is standing on the fact that we have already defined A triangle B to be what? A minus B union B minus A.